Hello everyone, I am Shubha. Today I am going to introduce my research topic to you. The title of my work is Non-Invasive Way of Lithium Detection Using Ultrasensitive GFET based Wearable sweat sensor. The keywords for this research topic can be viewed from the title as like Non-Invasive Way, GFET, Wearable sweat sensor. So let's begin. I have organized my presentation into four major sections. As a research problem, I will discuss why lithium detection in blood is actually necessary and what are the problems of invasive way of lithium detection, which is actually involve the blood sampling process. And then I will talk about my research goal, where I have taken a new approach for lithium detection, which is actually non-invasive way. And I will discuss why this non-invasive way of detection is preferable over the invasive way of detection. Later on, I will propose my hypothesis about how the non-invasive way is going to work here, and I will discuss about the testing procedures of how to test this hypothesis. We all know that lithium is widely used as a mood stabilizer drug, which is mainly used for bipolar disorder treatment and depression treatment. But the problem is that it has a very narrow therapeutic level, which is actually 0.5 millimolar to 1.5 millimolar. That means below the range of 0.5 millimolar, lithium is actually ineffective, and while the level of above 1.5 millimolar causes toxicity, and the level of toxicity is so high that even the kidney, the liver and our brain can damage because of excessive lithium level in blood. Most importantly, if the level of lithium is more than 5 millimolar, then even a patient can die. So when a patient is treated with lithium based drug, the level of lithium should be closely monitored in the blood so that it's not actually crossing the danger level in the blood. As a result, constant monitoring of lithium is essential when patient is taking lithium based drug. Conventionally, lithium level in blood is actually measured by different laboratory approaches like voltammetry, potentiometry, etc. The main problem with all of these laboratory approaches is that they need to extract blood sample from a patient, and we all know that blood test is a costly procedure and it needs a healthcare professional to extract the blood sample and to evaluate the result. So there always remain a time delay between the processes. Thus, the early detection and timely figuring out the problem is not possible, since this is a time dependent process. So to overcome this problem, few point of care like devices were developed, like paper based potentiometry, finger stick devices. But one of the potential problem with all of these POC devices is that the environment and the healthcare personnel actually been exposed to blood-borne diseases when collecting the sample of blood. And another actually most problem that patient have to undergo during invasive way of lithium detection is that when patient have to go for frequent blood sampling, it is actually very painful for them to extract blood sample more and more. So that's why we are looking for some other way than this invasive way of lithium detection, so that we don't need to work with blood sample anymore. Rather than we will look for some other way so that we can detect lithium without using any blood sample. Non-invasive procedures actually involve the use of biofluids like tears, sweat, saliva, interstitial fluid, and this biofluid actually contains physiologically relevant materials, metabolites, electrolytes in our body. And our aim of this study is to detect lithium using these non-invasive biofluids, and we are aiming to develop a wearable sensor that will detect lithium from sweat excretion, and this level of lithium from sweat will be directly proportional to the lithium level in blood. So our device will actually work as like a POC device that will get the result instantly. The main difference between our device and invasive wave detection is that we don't need to go anymore to the healthcare center for a blood test to detect lithium level. Rather, we can do it using a simple sweat sample from the patient. Study of Kishore showed that our kidneys are actually responsible for 95% of lithium excretion, and rest is removed through sweat and feces. Another study of 2004 showed that lithium concentration in interstitial fluid, that means the non-invasive fluid, is directly proportional to the lithium concentration in serum. So our hypothesis is that since lithium is excreted through sweat, so we can detect this lithium by using a well-developed sweat sensor, and we can proportionally correlate this lithium level to the actual lithium level in blood. So our aim is to detect lithium level from the sweat and then to propose the actual lithium level in blood. Since the level of lithium in sweat is very little, so the level of sensitivity of the sensor should be high enough so that it can accurately detect all the lithiums from the sweat sample. So in order to achieve this goal, we are actually going to FET based sensor, and FET based sensor are actually widely used for DNA sensing, RNA sensing applications, which are actually non-wearable process. But because of ultra sensitivity of this device, we are trying to use this non-wearable sensor to give a form as wearable device. Additionally, we are trying to use graphene with the FET so that the sensitivity of the device can be increased, because graphene is widely known for high electron hole mobility, and with the level of sensitivity we need to make the device more selective, because in the sweat there are some other fluids that are actually not required for us. So this ion selective membrane will selectively pass lithium to the graphene film, and thus we will detect the lithium using the GFET sensor. So our testing procedure actually involved the fabrication of a FET sensor on a flexible Kapton substrate, and then transferring a graphene monolayer on the source and drain of FET. Later we will develop a lithium ISM and will be deposited on the FET. We will actually characterize this sensor using artificial sweat, and we have planned to interface this sensor with mobile application for data visualization. So far we have already fabricated a flexible GFET sensor. The picture is shown right here. So that's all about my presentation. Thank you.